US Physics Olympiad year 2015. USA PHO Final Exam. This exam consists of 6 problems, Part A 4 problems and Part B 2 problems. For each part they were given 60 minutes. Solutions for all problems you can find below this video in the reference of the description. If you want to check many other problems from US Olympiad or whatever, you can subscribe to this channel. Problem A. Consider a particle of mass m that elastically bounces off of an infinitely hard horizontal surface under the influence of gravity. The total mechanical energy of the particle is E, and the acceleration of free fall is g. Treat the particle as a point mass and assume the motion is non-relativistic. Question A. An estimate for the regime where quantum effects become important can be found by simply considering when the de Broglie wavelength of the particle is on the same order as the height of a bounce. Assuming that the de Broglie wavelength is defined by the maximum momentum of the bouncing particle, determine the value of the energy EQ where quantum effects become important. Write the answer in terms of sum of all, or G, M, and the Planck constant H. Part B. A second approach allows us to develop an estimate for the actual allowed energy levels of a bouncing particle. Assuming that the particle rises to a height h, we can write this equation, where p is the momentum as a function of height x above the ground, n is non-negative integer, and the h is Planck's constant. First, determine the allowed energies En as a function of integer n, and sum all of G, M, and Planck's constant H. 2. Numerically determine the minimum energy of a bouncing neutron. The mass of a neutron is this one in kilograms or mega electron volts per c square. You may express your answer in either joules or electron volts. 3. Determine the bounce height of one of these minimum energy neutrons. Part C. Let E0 be the minimum energy of the bouncing neutron and F be the frequency of the bounce. Determine an order of magnitude estimate for the ratio E over F, if only needs to be accurate to within an order of magnitude or so, but you do need to show work.